All right, so what we're going to do is we're going to get a little preview of some application problems that we're going to set up, and we're going to use matrices to solve, okay? So this will just kind of get us started when you come into class. It'll help having seen a couple worked out. Hopefully it'll help you be a little bit more independent. All right, so what I need you to do is get your notebook, title a new page, and then I want you to hit pause, and I want you to copy this problem down. It'll help the video go a little bit quicker, okay, if we don't walk through together writing it all down. So hit the pause key, write everything down, and when you're ready, hit play, and let's walk through this example together. All right, let's read through this problem. The sum of three numbers is 165. The middle number is half the largest. The smallest number is 23 less than the middle number. Find the three numbers. Now, a lot of times what happens when you read these is you pretty much leave the problem after you're done reading thinking, where do I begin? This is where you're going to start. I want you to start by figuring out what your variables are. It's very difficult to write a system of three variables if you don't know, okay, what your variables are in the first place. Well, it says to find the three numbers. So what if we let the three numbers be represented by X, Y, and Z? And I can tell from the language of the problem that one of the numbers is going to be the smallest, one of the numbers is going to be the middle number, and one of the numbers is going to be the largest. Okay, so now that I am more aware of what my variables are, let's write a system of equations. Okay, well, if I have three unknown variables, I'm going to have three equations. So that's the general rule. If there's two unknown variables, you're going to have two equations. Well, the first piece of information, okay, that we're going to see is the fact that right here, it says, okay, that, I'm going to do this one in purple, that the sum of the numbers is 165. And so what that means, my first equation is going to be X plus Y plus Z, and the sum of the first, the middle, the smallest, the middle, and the largest is 165, okay? So then we keep going, I keep reading, and the next equation that I see is going to be the middle number is half the largest. So that right there is going to be my second equation. Well, the middle number is Y. Is represents the equal. That's an important word that helps me when I write the equations, is it helps me make sure that I put the equal sign where it belongs. And then it says half, and the largest number is represented by Z. So let's translate this. It's going to say Y equals, the middle number is 1/2 the largest number. Okay? So once you really kind of interpret word for word, these really aren't too bad. Here's my last equation. The smallest number is 23 less than the middle number. Okay, the smallest number is, well, the smallest number is represented by X. Is means equals. And in this part, we need to be a little bit careful. So we're going to say X equals. When they say 23 less than the middle number Y, we need to be careful because that actually means that it's the 23 that's being subtracted. Okay, so those are my three equations. You can see the color coordinated tells you what part of the problem that it came from. So the next thing that we're going to do if we want to use a matrix to solve this is we need to write each equation in standard form, meaning we need to make all of the equations look like the first one that's in purple, where all three variables are on the same side. Okay, I'm going to scooch that over just a little bit, just for the sake of spacing. All right, so X plus Y plus Z is equal to 165. Now, the second one we need to be careful. What we're going to do over here in the green is we're going to minus over the 1/2 Z. Okay, so what's this going to look like? Well, we're going to have 0 X's in this equation. There's going to be a 1Y, because you can see that there's already a 1Y that's over here on the left. And then what I'm going to do is I'm going to minus the 1/2 Z. And what is that going to leave me? If I minus the 1/2 Z over, what's that going to leave me with right here? Well, that's going to leave me with 0. Okay? So let's get this last equation in standard form. Well, I can already see here that I have a 1x already on the correct side. So I'm going to put 1x. I'm going to minus the y over, which is going to give us negative 1y. There are 0 z's in this equation. And again, if you minus this over, what are you left with? And you can see that you're going to be left with negative 23. Okay, So the next step here that we're going to do is we are going to write an augmented matrix. Okay, we're going to write an augmented matrix. All right, and so what we're going to do to set this up is we are going to let the rows be equations 1, 2, and 3. Everything's lined up nice here. The columns are going to be the coefficients of x, the coefficient of y, and the coefficient of z, and then we're going to put this dot dot that's going to represent the equal sign, and we'll put the constant number that it equals. So my first equation right here is going to be 1x, 1y, 1z, dot dot, 165, right? You can see right here that all of these coefficients are 1. The second equation is 0x, 1y, negative 1/2 z, dot dot, 0. Okay. The third equation is going to be 1, negative 1, 0, and negative 23. Okay, so hit pause if you need to. Take a look at where that came from. And when you're ready, I need you to go get your graphing calculator. And so what we're going to do is we're going to enter this matrix into our graphing calculator. All right, so let's just kind of review how to put this into how to edit a matrix. We're going to hit second matrix. You're going to go over to edit. Now you might already have something in matrix A, but it's not a big deal. You just come over here and we're going to enter this matrix in as a 3x4. Okay, just real quick, I'm going to go back to this. Remember, when we go to enter this in our calculator, we don't enter in the dot dots. And so in fact, this matrix right here has 3 rows and 4 columns, so we're going to enter this in as a 3x4. All right, so let's go over now. We're in edit. Let's start typing in the numbers. 1, 1, 1. Okay, you take your time with this. If I type too fast, just again hit the pause key, finish typing, make sure everything's correct. Negative 1, 0, negative 23. Okay, now this is where I'm going to have to talk you through the rest of it because this graphing calculator does not have reduced row echelon form. Again, this is kind of a Texas Instrument knockoff, so it's not exactly the same as yours, but it's good enough. So when you're done, I need you to hit second mode and go into their blank calculator screen. You can go ahead, if you have any calculations here, you can just clear everything out, okay? So what this is going to look like, okay, is you are going to hit second matrix, right? You're going to go back into that matrix menu. And this time, though, I want you to go over to the math key. And you're going to, once you're in that math menu, right? I can kind of show you that. I just don't have anything in it. Once you're in your second matrix, go over to the math key. And I need you to hit the up button. And I need you to find rref. I like hitting the up button because rref is at the bottom of the menu, so you'll get there quicker. All right, so here's what your calculator screen is going to look like. Once you go and you hit enter for rref, it's going to say rref parenthesis. Well, now what we need to do again is we need to hit second matrix, but this time hit enter for matrix A and pull matrix A out into your home screen. And what you're going to get, if we did this right, is you should have 1, 0, 0, 24, 0, 1, 0, 47, and we've got 0, 0, 1, 94. And again, we talked about this a little bit in class about how what rref does is it turns this into the identity matrix, okay? And your solutions here, if this is x, this is y, and this is z, this is going to mean that 1x is equal to 24. This means 1y is equal to 47, and 1z is equal to 94. And so what we can do to answer the question, it says, what are the numbers? Well, the numbers are 24 for the smallest, 47 for the largest, or the middle, and 94 for the largest. If you did not get those numbers, you did not get this matrix after you did rref, go back into second matrix, go back into edit for A, and just check that augmented matrix, and I guarantee you're probably going to find one number you typed in wrong, or maybe you missed a negative. It's going to throw your whole answer off, so you can repeat the steps if you needed to fix a number and go back into it. Okay, we're going to go over one more problem, and like I said before, hit the pause key, copy down the problem, And we'll resume when you're ready. Hit play and we'll read through the problem and get started. All right, let's read through this. A coin bank has pennies, nickels, and dimes. There are 156 coins, and the value of the coins is $6.93. If there are 12 more dimes than nickels, find the number of each type of coin. So I think it's important after you read these, okay, that so often what happens is you're going to read it and you're going to be confused. Just plan on it, know it, okay? We don't go into these and start finding the answer. We don't go into it and start writing the equations. All we need to do when we read it for the first time is figure out what your variables stand for. Well, it says find the number of each type of coin. Well, they tell me in the beginning that I have pennies and nickels and dimes. Let's try this time instead of using X, Y, and Z. Okay, sometimes when the variables are appropriate, I like to sometimes use the variable to kind of represent what it stands for. So let's say P equals the number of pennies, N will equal the number of nickels, and let's say that D equals the number of dimes. Okay, let's try it this way and maybe it'll help us kind of set up the equations. So now what we're going to do is now we go into the problem and we know that we need 3 equations because we've got 3 variables. Then I can slowly reread the problem and make some sense out of it and start writing my equations. But please don't think that the very first time you read a problem, you're going to know exactly how to set up those equations. Okay, first equation. There are 156 coins. That right there is going to be an equation. That means that the number of pennies plus the number of nickels plus the number of dimes is going to equal 156. Okay? Your second equation is going to come from this part. Okay? The value of the coins is $6.93. Well, to get the value to be $6.93, we need to multiply the money value by the number of pennies. Well, a penny is worth 0.01. So 0.01 times the number of pennies. Nickels are worth 0.05, times that by your nickels, and dimes are worth 10 cents, so multiply it by 0.1. And when you multiply this dollar amount by the number of coins, that's how you're going to get it to equal $6.93. Okay? So one of your equations was for the total coins and one of your equations was how much the coins were worth. This last equation is a little bit tricky. There are 12 more dimes than nickels. Okay? It's not as straightforward as example 1 because I don't see that word is where they're telling me where the equal sign goes. So where we need to be careful with these is the mistake that people make is they see 12 more dimes than nickels and they want to say 12 plus dimes equals nickels. The problem is that this is incorrect. So what I do when I hear these types of things is these comparative statements, I think of this picture in my mind. I think to myself, okay, which type of coin has more? Okay, one of these coins has 12 more than the other. So in my head, I think of 2 stacks where one has more than the other. Okay, which one has more? The dimes has more. Okay, so your D, your dimes, okay, is right here. This is your dimes, and this is going to be your nickels. So the question becomes, which variable do you want to add 12 to? Are you adding 12 to the dimes? Is that where we're going to add 12? No. What we want to add 12 to is we need to add 12 to your nickels. If you take the nickels plus 12, then we can see right here that your stacks will be even in size. Okay, so just a little illustration there, but think about that it's actually this stack that we want to add the 12 to. And so here's my last equation. It's going to be dimes equals the nickels plus 12. Now, that is not the only way that we could set this up. You could also do it where maybe you decide to take your dimes and maybe you decide to minus 12 from the dimes. If you took the dimes minus 12, then that would equal the nickels. This is the same equation. So we'll work on that more in class, but I do want you to be careful with those comparative statements. All right, let's just take a quick second and let's get our equations in standard form. All right, so I know that this one already is. P plus N plus D equals 156. 0.01 P plus 0.05 N plus 0.1 D is equal to $6.93. Now, this last equation, there are 0 pennies in this equation. I'm going to minus over the n, okay, and it's going to make your n right here. I'm going to get rid of this plus sign. This is going to be minus n, okay, and then I'm going to have plus 1d. And so you kind of have to see here that when you subtract the n from the other side, you're going to have negative n plus 12 is equal to d. So that's what I said. 0p, negative 1n, positive 1d, and it's going to equal 12. All right, take a second to hit pause if you need, if you want to look back over the math of what I did right there with that last equation. When you're ready, let's make our augmented matrix. I'm going to let this column be pennies, nickels, and dimes, dot, dot. We're going to put what it equals. So this first equation's easy. It's going to be 1, 1, 1, dot, dot, 156. The second equation is going to be your Voni value, 0.01, 0.05, 0.1, dot, dot, $6.93. This last equation has 0 pennies, negative 1 nickels, okay, because of the way we subtracted that, 1 dime, and 12 is the number. Okay, now's the part where we need to go into our calculator, and we're going to go over to second matrix, we're going to go over to edit, and again we're going to put in a 3x4. So again, I don't ever delete matrices, I just go in, change the dimensions if I need to, and I just start writing new equations. Okay, so just go ahead and type over the old entries. Go ahead and do this at whatever speed you need to. I think I did this right. 0.05. There we go. Point 1. Okay, $6.93. And then we have 0, negative 1, 1, 12. Okay, give that a double check to make sure everything got entered in right. Okay, when you're ready, hit second quit, and this is the part where I'm going to walk you through it because I don't have that in my calculator. Okay, so what you're going to see on your screen, let's hit second matrix. Let's hit second matrix, let's go over to math, and again, hit that up button, and let's look for B, which is rref. Make sure you get that double R. Now let's hit second matrix again and pull out matrix A, and when you're ready, make sure you hit enter. Okay, make sure you hit enter. And when you hit enter, here's what you're going to see. It's going to say 10078. Okay, it's going to say 01033, 001 45. Because of this main diagonal having the ones, that means that there's one unique solution. All right, so this is where it helps me to label my columns pennies, nickels, and dimes. So what this means is that your pennies is equal to 78. Your nickels is equal to 33, and the 1 is under D, so that means that this is going to be your dimes. So the last thing that we need to do is put your answer in context. Don't just write to me 78, 33, 45. There are 78 pennies. For the nickels, there are 33 nickels, and for the dimes, there are 45. Okay, so that's going to get us started. I just know sometimes the hard part is writing the equations, and I definitely thought maybe we could use a once-over on how to use that augmented matrix and solve a system of 3 variables. Okay, we'll pick up from there in class. See you next time.